Welcome to our next level 3 probability distributions video. This is our third video for Poisson distribution. We have a lot to get through, so let's get straight into example 1. It's about our Pacific region that experiences each year on average 2.6 earthquakes that measure over 4 on the Richter scale. What we're going to do is show you some tricks to do on the calculator to help you solve some problems. So part A. What is the probability there are 3 or less earthquakes that measure over 4 on the Richter scale in a year? Well, we showed you how to set up a probability distribution table and a graph, and lambda, which is our expected value or mean, is 2.6 per year. And when we say 3 or less, we're talking about the probabilities of 3, 2, 1, and 0. Now, if you have a table set up, you can just add those up. But we're going to show you how to do this on a calculator. So we're going to go into Poisson distribution. We're going to go into Poisson cumulative distribution, which sums things up. We're going to go into variable, and we're going to enter in our parameters. Now, for x, we're going to put in 3. Now, if you remember the binomial distribution, it's set up in exactly the same way. The calculator can't be changed. It's set up to add up all the probabilities less than or equal to some number called a. So when we type in x is 3, it's going to add up 3, 2, 1, and 0, which is exactly what we want for this first problem. Our mu, remember it's lambda, but in the calculator it's called mu, so don't get stressed about that. Our mu is 2.6, and let's get the probability of 0.7360. So the probability of less than or equal to 3 or less, is 0.7360. All right, part B, what's the probability there are less than 3 earthquakes that measure over 4 on the Richter scale in a year? So once again, I say less than 3. Because it's discrete data, I can't have 2.8 or something. I have to have whole numbers, so it has to be either 2, 1, or 0. So once again, we go into Poisson cumulative, and we're going to enter in our parameters. This time we have to enter in x is 2, because we want less than 3. We can't put 3. So we're going to put x is 2, which adds up 2, 1, and 0. We're going to put our mu is 2.6 lambda, and that gives us a probability of 0.5184. So the probability of less than 3 is 0.5184. All right, now we're on to a bit trickier. Part C, what is the probability there are more than 2 earthquakes that measure over 4 on the Richter scale in a year? Well, once again, I say more than 2. Now, more than 2 means either 3, 4, 5, 6. Remember, there's no upper limit, so that can keep going forever. More than 2, I don't include 2. So greater than 2. Okay, so we're going to Poisson cumulative once again, and we're going to enter in our parameters. But remember, the calculator is set up to be less than or equal to some number. So we've got to be clever and say, because we want more than 2, which is 3, 4, 5, 6, and so on, we're going to put it x is 2, and it's going to calculate 2, 1, and 0 for us. That's what the calculator is going to calculate. And that gives us the probability of 0.5184. But I don't want that section. I want the other section. So remember the little trick we did in binomial, where we're going to take it away from 1 representing 100%. So if we go 1 minus 0.5184, it gives us the other section, which is what I want, 3, 4, 5, 6, 7, 8, 9, and so on. So that gives us a probability of x greater than 2 or more than 2 of 0.4816. And finally, what is the probability there are at least 4 earthquakes that measure over 4 on the Richter scale in a year? So again, I'm saying at least 4, which means I want 4 or more. So when I say at least, I want to include 4. So once again, we're going to enter in, we're going to be clever and put x is 3. The calculator is going to calculate 3, 2, 1, and 0 for us, that section. It's going to work out that probability, which is 0.7360. I don't want that section, I want the other section, so I'm going to be clever and I'm going to subtract it away from 1. 1 minus 0.7360 gives us a probability of greater than or equal to 4, at least 4, equal to 0.2640. Right, thanks so much for watching.